Why is the ocean salty? Rivers carry dissolved salts to it. The ocean keeps salts. Rivers and most lakes flush them. Rain and carbon dioxide make a weak acid. It weathers rock. Minerals dissolve into water as ions. Rivers deliver salts for ages. The ocean is the final basin, so salts accumulate. Most lakes have an outlet. Water passes through and carries dissolved salts away, so lakes stay fresh. Sunlight evaporates only pure water from the ocean. Salts are left behind, gradually raising salinity. Rivers flow downhill continuously toward the ocean. They don't store salts. The load keeps moving downstream. Some lakes are closed basins with no outlet. Evaporation removes water. Salts stay, making them very salty. Over long times, inputs and removals balance. But because oceans keep salts better than rivers and lakes, they remain salty. Most ocean salt comes from dissolved ions in rocks and vents. Sodium and chloride pair up to make common salt. Some ions leave the ocean by forming minerals and shells. They sink as sediments, trimming part of the salt input. Evaporated water makes clouds and returns as fresh rain. Rain feeds rivers that carry more salts toward the ocean. Rivers deliver salts, oceans keep more, lakes flush most away. Hence, oceans stay salty while rivers and most lakes stay fresh. Hydrothermal vents add dissolved ions from Earth's crust. Those inputs join the ocean's salt supply. At river mouths, fresh water mixes with ocean water. Mixing lowers salinity near coasts compared with open ocean. Where evaporation is strong and rain is scarce, salinity rises. Rainy regions and ice melt dilute the ocean's surface. Winds and currents stir and spread salts through the ocean. Mixing keeps levels fairly steady across wide areas. When ocean ice forms, most salt is pushed into nearby water. Ice is nearly fresh. Brine makes surrounding water saltier. Ocean water is too salty to drink. Rivers and most lakes stay fresh because salts flush out. On average, ocean water holds about 35 grams of salt per kilogram. Scientists track salinity to see takeaway. Rivers and vents add salts. Evaporation leaves them behind. Rivers and most lakes flush, but the ocean keeps more, so it stays salty. Salinity shifts with seasons. Rain and meltwater dilute near coasts. Dry spells let salt concentrate. Winds mix the surface, while deep water moves more slowly. Together, they spread salts and smooth out extremes. Over millions of years, salts lock into sediments and new rocks. Uplift and weathering restart the journey back to rivers. Desalination pulls fresh water through a membrane. Salts collect in brine, which must be handled carefully. Evaporate salty water in a tray. Water vanishes. Tiny crystals remain. Salt stays behind. Add salt to water and density rises. An egg sinks in fresh water but floats in salty water. Many ocean animals manage salt. Birds shed it with special glands. Fish balance it through gills. Where rivers meet the ocean, water turns brackish. Many plants and animals are adapted to that in-between saltiness. Check. Salts flow in from rivers and vents. Evaporation leaves them. Lakes flush, but the ocean keeps more. Rivers bring salts. Evaporation leaves them. Lakes flush. The ocean keeps more, so it stays salty. Question solved.